All right, page 3 here. This one says no calculator. The other two would have been no calculator as well. The function, graph of the function f, again, this is f, consists of 3 line segments. So that means that we can make geometry shapes out of this. Let g be the area from 1 to x. Calculate g of 4 and g of negative 2. Okay, so here's one where we're going to have to pay attention to our bounds. So let's start with g of 4. So what's g of 4 going to equal? It's going to equal the integral from 1 to 4 of f of t dt. These limits of integration are in the correct order. The lower number is on the bottom, so I don't have anything to change around. So now I'm just finding the area from 1 to 4. Now, I'm noticing that the area from 2 to 3 and 3 to 4 is equivalent, right? One's positive, one's negative. So those are going to add up to 0. So I'm really only going to find the area of this one. So it's positive, it's 1/2, times the height, which is 1, times the sum of the bases, 4 plus 1. So g of 4 is equal to 5 over 2. So that's part 1. What about g of negative 2? So in the first integration packet, some of you were struggling with this idea of like, where is g of negative 2? And should I be adding or subtracting areas? So don't overthink it. If the limits of integration are backwards like this, just flip it around. So how do we do that? We make it negative integral, put negative 2 at the bottom and 1 at the top. So you're going to have a negative outside of whatever your area is, and just do the area like you normally would. We're going from negative 2 to positive 1. So it's the area of this triangle, which this area is positive 1/2, times the base, which is 3, times the height, which is 4. And then the reason I'm going to get a negative is because we were originally going backwards. So there's a negative out here. So even though this is a positive area, the integral from the area from 1 to negative 2 is going backwards. So anyway, g of negative 2, just let the algebra work for you, is equal to negative 6, half of 12. Okay, find the instantaneous rate of change of g with respect to x at x equals 1. So that's just a fancy way to say find g prime of 1. And how does g prime relate to f? So remember, g prime is taking the derivative of an integral. So the derivative and the integral cancel out. These cancel out. This expression, it happens to just be x, but if it's 2x, 4x, x to the 8th, whatever, it goes into the function. So it's equal to f of x. And then the reason I'm stressing this point is because I want you to get in the habit of doing this. The derivative of x is 1. If this is x squared, the derivative of x squared is 2x. So that matters. That will come into play at some point in this packet. So g prime of 1 is just equal to f of 1. And f of 1 is equal to 4. So g prime of 1 is equal to 4. Part C, find the absolute minimum on the closed interval. Justify your answer. So this is extreme value theorem. We write out the candidates, which are the endpoints. The endpoints and the relative minimum if there is one. So endpoints first, so we don't forget about them, negative 2 to 4. And then is there a relative minimum? There'd be a relative minimum where g prime changes from negative to positive. And remember, g prime is f. Does f ever change from negative to positive? No, it changes from positive to negative, but there is no relative minimum. You don't have to write no relative minimum for your AP test. That's just for you. Okay, so g of negative 2, we already found these values, right? So we don't have to show the work again. That's negative 6. G of 4 was 5 over 2. So what's the absolute minimum? So right there. So find the minimum value. It's not the x value. The absolute minimum is negative 6. You can say at x equals negative 2 if you want, but you have to say that the minimum is negative 6. All right, and then part D. The second derivative of g is not defined at 1 and 2. How many of these values are x-coordinates of points of inflection on your graph? So the second derivative, g double prime of x, is equal to f prime of x. And we're looking for where g double prime changes sign. So if you want to make a little chart for yourself, you can. 1 and 2. Remember, AP is not going to grade this, so this is just for you to keep in mind. So for g double prime equals f prime, so what's happening to the left of 1? So to the left of 1, the slope is positive, so f prime is positive. Between 1 and 2, right here, the slopes are negative. Slope changes to negative. And then after 2, the slope is still negative here. So there's not a point of inflection at 2 because g double prime has not changed signs, but there is 1 at 1. So x equals 1 is a point of inflection because g double prime of x equals f prime of x. Changes signs. You can say changes from positive to negative, but that part doesn't matter if it's just a point of inflection.